Hello friends, this is the 7th video tutorial into the video lecture series on machine learning. So in earlier lecture we have seen that to dive into machine learning related programming, if you want to do into Python, what are the prerequisites required. So from now onwards, some couple of videos I am making onto the programming prerequisite required for the machine learning. So in this tutorial we'll see about the numerical Python library available inside the Python. So I have divided every numerical Python library into two parts. So in this tutorial we'll see about the how to create the arrays. So I have divided the whole topics into this number of subtopics, like uh, how to import the numerical package, how to see the documentation, how you can create the arrays inside the numerical Python library, and how you can index it. In the second tutorial we'll see about what kind of operation you can perform onto it. So let us start begin with the very first subtopic, that is the import convention Python package. So what is the normal conventional way of importing the numerical Python library inside the Python? So generally we insert with like import numpy, and alias we give np, so every function we can access as the name of np. Okay, so it works very fine. The second one is numpy reference documentation. Now suppose you want to see any kind of documentation of a numerical Python library, so you just type, if you know already the function available inside the numerical Python library, and you just type np dot the function name and you put the question mark on it and run the cell. So it will just show the documentation associated with array function of the numpy library. Now suppose you don't know the actual function and you know the partial function name like a con, and you don't know what is ahead, then just put after con the question mark or star, then it will show us the list of function which is matching this criteria. So this is the way you can find the documentation of the Python. You put the question mark. Okay, so this is the. Now let's see the third one, that is a manual construction of the array. So why this array is much more related in our case with respect to the, first of all, with the machine learning. So the first task in machine learning is to importing hell lot of data, and those datas are arranged in a multi-dimensional grid. So this numerical Python library will gives us the ability to import those data in a very efficient way, plus manipulation on the top of it. That is what the objective of machine learning. That's why we are learning about this array manipulation stuff inside the numerical Python library. So let's see manual construction of array, how you can create the array very manually. So just now we have seen one function array, and you supply what are the value you want to put inside the array. So suppose 1 2 3 5 7. Okay, it has not displayed any output. Okay, uh, so we have created the one array which has stored a value 0 1 2 3 5 and 7. Now suppose we want to print that array, so it has printed 0 1 2 3 5 7. Let's see the size of this array. So there is one function a dot shape, that is a 6. So there are total 6 element inside this array. So this is the story about the one dimensional array. Suppose we want to create manually the two-dimensional array. So how we can create it? The same function we can use it, but you need to give the two-dimensional array. So suppose 3 comma 5 comma 7 1 comma 6 comma 3. Okay, there is one more braces I need to keep. That is just the matter of syntax. Now let's print how this b variable looks like. So it has a total 2 rows and 3 columns. The first row is 2 3 5 7 and second row is 1 6 3. Now let us print the shape of this array. Okay, so it has a the first element indicates the total number of rows, then the second one indicates total number of columns. So it has a 2 rows and 3 columns. Okay, so that's all about how you can manually create the array. But numerical Python library gives us different functions to create the array with the evenly spaced values you want to associate it with the arrays, or by total number of point you can supply and you can create the array. There are some common array function also. So let us see how we can do it. Now suppose we want to create the array from 0 to 100, which all element associated with that. So numerical Python has a one function a range. So suppose 20, so it will print all values between 0 to 20. Better we should have printed here only. So it has printed 0 to 19, so total 20 value which starting from 0. Now suppose we want to where we do not want value to start from the 0, or we want from suppose 3, then it will start from 3 to 19. Okay, so you can give starting value and ending value, but end won't be included. Now these are all values which is incremented by just the one step in future, but we want those all value which is in a step size of 2. So after every interval of 1, and this value will be printed. So see, it has printed 3 5 7 9. So in a step size of 2 it has printed. Now suppose we make it to step size of 4, so there is an interval of 4 between each and every value. So in this way we can create the array in a numerical Python library with evenly spaced value across the whole array. There is a one more function. By the number of points you can supply and you can create the array. For that Numpy provide the Linspace function. So what does Linspace function will do? You can give the start value and ending value, and you can provide the number of points or number of elements in the array you want to create. So suppose I want to create the 25 element. So what it will do, it will create the 25 element of array which is evenly distributed between the range 0 to 10. So between 0 to 10 it will divide evenly spaced 25 parts and it will generate the array. So let's print it. Oh, sorry, this we need to print D. Okay, so it has printed between 0 to between the maximum value 10 and minimum value 0, and it has divided whole range into 25 different parts. So if you keep the len function of D, then it will show there are the total 25 elements are there inside the array D. Now this is by the number of point. Let's see how the common arrays functions are available. So suppose you want to create the array which is having a exactly same value. So let us see np dot once. So it will create the array of 3 rows and a 5 columns, which is having all values will be 1 only, and will print e. So there are total 3 rows and a 5 column which is having all values 1. So this once function will create the array which is having all values 1. Now suppose we want to put all values like 7, so you just multiply it by 7 and it will print this, it will create the array of value all 7. So this is for the same value. Now suppose we want all values to be a 0, so either you can do it this way, it will generate the 0, or even Python will provide Numpy Python will provide one more function like np dot zeros. Again you supply the dimension of the array you want to create, suppose 4 comma 2. Okay, we need to print also. So it has created all array which is having a dimension 4 comma 2 and all values are 0. So this way, this is the specific kind of array also you can create it. Now let's see how we can generate the random number with the help of this numerical Python library. So there are two ways you can generate the random number. One is the uniform distribution way you can generate it, or one is the Gaussian distribution way you can generate it. So uniform distribution array will generate the value between 0 and 1. So let's see how uniform distributed way we can generate it. So let's assign to some variable g. So np dot, there is a one more package inside the numerical Python library, that is a random. So we are accessing those module within a package numpy library, that is a random, and inside the random there is a function like a rand. So rand function, you need to just supply the total size or of your dimension, so comma 2 comma 3. So this will generate the random number with a very uniform distributed way between 0 to 1, which is having a dimension 2 comma 3. So total 2 row and a 3 column. So print g. Okay, two dimensional array I don't think it can create, so we have to supply one dimensional way only. Okay, so it has generated total 3 values in a very uniform distributed way between 0 to 1. Now suppose we want to generate the value in a Gaussian distributed way. So there is the same package we can use it, but the function name is rand n. N means the normal distributed way, that is nothing but the Gaussian distribution. So suppose we want to create the and this will create the value between -1 to 1, which is having mean value will be a 0, and total 4 value it will generate. So print h. So it has generated between 0 to -1 to 1 in a Gaussian distributed way, and nothing but it is a normal distribution. Normal distribution is nothing but the Gaussian distribution. So this is how different ways we have created the array. Let's see about the basic data type associated with the numerical Python library. So we have created a lot of arrays earlier, like this C and D. Let's concentrate on this C and D. So we have seen that this C and array C, which is having all value, looks like a integer because we have generated value between 3 and 20, which is having a step size of 4. So it has generated all but here all values are float. So suppose we want to see the type of the array, then there is a one property associated with the function. You can write, let's print first C. Now we want to print C dot D type. So it has created integer 64-bit. So that means every element of this array which is having a size 64-bit. Okay, let's see about the array D. D dot D type. Okay, so it is having all value which is a 64-bit floating value. That's why it has printed 64-bit floating value. So these are the different data types inside the numerical Python library. There is one more complex 128-bit also, which is nothing but the real and imaginary part both are float 64-bit, and there is one more is a boolean data type also. So these are the different data type. Let's see about the how we can see the indexing of and a slicing of element. So we have already created a lot of array. Let's print array A. So A is having an element 0 1 2 3 5 7. Now suppose we want to access the third element. So in numerical Python Numpy library, all values starting from all indexing starting from 0. So we want element 4. So this is first, second, third, fourth. So we want to access the fourth. That means the third indexing we have to access it. That is nothing but the 3. Let's see about any 2-dimension array, how we can access it. Whether we have we have this any 2-dimension array. Yeah, we have a B is a 2-dimension array. So let's print it and let's extract the data out of it. So print B. Okay, so now suppose we want to print or we want to extract first row and the second column. So how we can do it in Numpy? The first row will be 0th index and the second column will be first index. So this is the 5. So first row and the second column will be a 5. That's correct. Now suppose we want to extract all rows. So if you put the colon, it will print all rows and only first column. So all rows and a first column. So it will be a 3 comma 1. So it should print 3 and 1. No, first means the second index. That means 5 and 7. Sorry about that. It is a 5 and 7. Now suppose we want to see just the 0th row and all column. So this is the 0th row and all columns. So it will print 3 and 5 and 7. So this way we can extract element or indexing will work inside the numerical Python library. So I want to show you there is a one good illustration has been given here. This is from the SciPy Science Python lecture.org website. So just consider this array. They have generated this arrays in a 2-dimensional grid. Let's just concentrate on this orange part. Suppose this is 3 and 4 out of this array we want to extract. So how we can extract it? So 3 and 4 lies into 0th row. So they have supplied here the 0th row, and this is lying into the third row and a third column and a fourth column. So we can extract it with the 3 to 5. The last value index will not be included. So in this way we can extract it. The same way let's concentrate on if you want to extract this red part. So this is the third column and all rows. So all row will be concluded with the help of just the colon. Colon means all value associated with that row will be extracted, and this is the third row. Third row can be extracted with the help of just second column. So we have extracted this red part. This is the third column. So this way we can extract element inside the numerical Python array. There is one more thing, and last one in this lecture, that is a memory efficient way. Now Python is already providing there is a range functions are there inside the Python. So it is nothing but kind of array for us. So let's see what is this range function, and how numerical Python array is giving advantages for us. So this is a range function, and I have installed one library which just find the time taken by that particular line or particular line of statements on a CPU to execute. Now suppose it has generated the all where array from range 0 to 999, and we want to have a square of each and every element of it, and let's try to find that how many seconds or how many milliseconds or microsecond it will take. So what it will do, it will do the squares of each and every element, and this range function I have used from the basic Python library, and let's see how much time it will take. This is the for loop actually. So we have to iterate it over all element. Of this range function, so of array L, so it has taken 60.8 microsecond per loop. Now suppose let's generate this same array with the help of numerical Python library, and we want to do the square of this numerical Python function. Time it and is 2. So this will do the exactly same operation what we have done with the help of for loop here, but here in a Python it will do in a very parallel, it will apply parallelism on the top of it, and it will do. Oh, there is a range function, not a. So see, it has given us that there are best of 3 result it has shown us, and it has taken just 1.56 microsecond, while in case of our basic Python data structure it has taken 60.8 microseconds. So you can imagine that how efficient and how fast this numerical Python function for data manipulation or matrix or linear algebra related manipulation. It is nothing but area oriented computing for people are using, and as it is very fast, it is very closer to the hardware. The way the computation happens on a hardware, it is very closer, that's why it's very fast. So it is better to use this numerical Python function rather than the actual Python built-in data structure. So that's it for this lecture, friends. So in this lecture we have seen about how to create the array, how to do indexing, and how memory efficient these numerical Pythons are there. In the next lecture we will see about how you can manipulate this array, what are the different operation you can perform on the top of it. All these things we can see from the point of view of the machine learning. I hope you enjoy this video. Thank you guys for the watching. Please do like, comment and subscribe it.